Bismillahirrahmanirrahim. Today we are going to do question number 5 and 6 of exercise 9.3, which is related to coterminal angles and their importance. Let me revise the definition of the coterminal angles. The angles having the same terminal ray when in standard position or in standard form are called coterminal angles. So all the angles which have the same terminal ray are called coterminal angles. Mathematically, if theta dash can be written as theta plus some multiple of 360, okay, 2 pi is equal to 360. If we can write an angle theta dash as theta plus some multiple of this, k can be any integer, okay, it can be a positive integer or a negative integer. If theta dash can be written, if you have two angles theta and theta dash, if theta dash can be written as a multiple of 360 plus theta, then we say that these two angles are coterminal. Okay, the important result which coterminal angles gives us that all coterminal angles have the same trigonometric ratios. So if you know the trigonometric ratios of theta, you can find the trigonometric ratios of theta dash with the help of trigonometric ratios of theta. If theta and theta dash are coterminal, then they will have the same sine, they will have the same cosine, similarly they will have the same tangent, cotangent, and so on. So if you know the trigonometric ratio of theta, and you can write some other angle theta dash as a multiple of 360 plus theta, then it means that theta and theta dash are coterminal. So if you know the trigonometric ratios of theta, you can find the trigonometric ratios of theta dash if these two are coterminal. So for example, the example of suppose if theta is equal to 30 degrees, okay, and theta dash is equal to 390, then theta dash, which is 390, can be written as 30 plus 360, okay, or it can be written as 30 plus 1 times 360. So as you may see, I have written 390 as 30 plus some multiple of 360. Okay, k over here is 1. Okay, our theta is 30 degrees and theta dash is 390. Now we don't know the trigonometric ratios of 390, but we know that we know the trigonometric ratios of 30. But now we have proved that 30 and 390 are coterminal angles. So with the help of the trigonometric ratios of 30, we can find the trigonometric ratios of 390, because these two are coterminal, and coterminal angles always have the same trigonometric ratios. So it means that if you want to find the sine of 390, we know that it must be equal to the sine of 30, because 30 and 390 are coterminal, and we know that sine of 30 from our previous knowledge, we know that sine of 30 is equal to 1 by 2. So sine of 390 will also be equal to 1 by 2. This is how we find the trigonometric ratios of angles which are coterminal to 30. Similarly, if you want to find cos, then cos of 390 will be equal to cos of 30, and that is equal to under root 3 by 2. We know that cos of 30 is under root 3 by 2. This from our previous knowledge from class 10. We know from there that cos of 30 is under root 3 by 2. So if you know the cos of 30, you can find the cos of 390, because they are coterminal, and coterminal angles always has the same trigonometric ratio. Similarly, tangent of 390 will be equal to tangent of 30, which is equal to 1 over under root 3. And similarly, from here we can find the cosecant. Cosecant of 390 will be the reciprocal of sine of 390, that is 2 by 1, which is equal to 2. The secant will be the reciprocal of this 390 is equal to 2 over under root 3, and cotangent of 390 can be easily taken from this expression under root 3 by 1. So this is how we can find the trigonometric ratios of any angle which is coterminal to 30, or which is coterminal to 60, 45, 30, 65, 60, 45, 90 degrees, 180 degrees, 270 and 360. These are the special angles whose trigonometric ratio we already know. So we are going to find the trigonometric ratios of other angles which whose trigonometric ratios we don't know about, but we can find it by proving them coterminal to some of to any one of these special angles, 30, 60, 45. These are the special angle that we have. These are special because we know their trigonometric ratios. So let us try question number 5 and 6 now. Now question number 5 is that we have to find the trigonometric ratios of this angle. Now we know that this angle is not one of these angles. These are the special angles which we are going to use, or with help of which we are going to find the trigonometric ratio of this angle. Now in order to prove that it is coterminal to one of these angles, we have to write this as a sum of one of these angles plus some multiple of 360. For that, we have to bring this expression theta dash is equal to k times 2 pi or 360. If the angle is in degrees, we are going to write. So if we can write 1530, okay, theta will be one of these angles, these special angles, and theta dash will be the angle which is given to us in the question. We are going to express this angle as a multiple of 360 plus, this is called multiple of 360 because k is any integer, k is element of an integer. So if we can write 1530 as a multiple of 360 plus one of these angles, then we can prove that this angle will be coterminal to one of these angles, and then we can find the trigonometric ratios of this angle. For example, if this angle comes out to be coterminal to 30 degrees, then it will have the same trigonometric ratios as 30. So we have to prove that this angle can be written as some theta which will belong to this group plus some multiple of 360. We have to write this. So here the role played by this angle will be theta dash. Okay, this will be our theta dash. Theta we are going to find which angle will suit us, and we are going to find k, that how many times 360 plus one of this angle will be one of this one. K will be some integer that we are going to find, and our theta dash is 1530. This will be the angle which is given to us in the question, for which we have to find the trigonometric ratio. Take that angle to be equal to theta dash. Now we have to find, this is our theta dash, we have to find theta, this special angle, which one of these will be coterminal to this angle, that will be the theta, and k will be one of the integers. We have to find k as well as theta, these two unknowns. If we can find these two unknowns, then we can easily express 1530 as in this form, okay, and which will prove that it will be coterminal to some angle theta. So we have to complete this expression. For that, theta dash will always be the angle which is in the question. Okay, to find k or approximate value of k, okay, this will give us at least approximate value of k. For this, what we are going to do, you are going to divide theta dash by 360. Okay, if the angle is in radian, we will divide by 2 pi because 2 pi equals to 360. But if the angle is in degrees, as it is in here, we are going to divide theta dash, the angle which is given to us in the question, by 360. Okay, this will give us the approximate value of k. Okay, 360. Now dividing these two, we are going to get, if you make use of the calculator, 1530 divided by 360 gives us 4.25. As k is an integer, so pick 4 only. Okay, this is just an approximation of k. Okay, we have to try whether k suits this expression or not, but this will give you the approximate value of k. Let k be equal to 4. Okay, take the whole number only, not the decimal part. K will be the whole number of this number. K is equal to 4. So we have obtained k. Now the only thing that we have to find is theta. Now from this expression, the formula for theta can be theta dash minus k times 360. Now theta dash was the angle that was given to us in the question, 1530, minus k, we have approximated it to be equal to 4. Okay, so it means that theta will be theta dash minus k times 360, because I have shifted this to the left hand side to find the value of theta. Okay, theta will be one of these special angle. Okay, so theta dash is equal to 1530 minus 400, 4 times 360. So calculating this by using calculators, this comes out to be equal to 90. Okay, this is equal to 90. So we have obtained an angle which belongs to this group. We know the sines are cosines of 90. Okay, so it means that theta, now filling this expression, theta dash is equal to theta plus k times 360. Theta dash is 1530 equals to theta is 90 now, plus k is 4. So it means that 1530, we have been successful in writing 1530 as a special angle plus some multiple of 360. So it means that 90 and this angle, both these are coterminal. Okay, according to this definition, if theta dash can be written as theta plus some multiple of 360, then these are called coterminal angles. So it means that 90 and 1530 are coterminal angles, so they will have the same trigonometric ratios. So to get the trigonometric ratios of 1530 that they have asked us in the exercise, sine of 1530 will be equal to sine of 90, and we know that sine of 90 is equal to 1. Similarly, cos of 1530 will be equal to cos of 90, which is 0. And tangent, we can easily find the tangent by dividing these two. Tangent of 1530 will be equal to tangent of 90, which is equal to undefined. Okay, because it is 1 by 0, which is an undefined. From here we can find its cosecant. Cosecant will be cosecant of 1530 will be the reciprocal of its sine, which is 1 by 1 equals to 1. Secant will be the reciprocal of cos of 1530. So it is going to be 1 by 0, which is, okay, 0 by 1, its reciprocal will be 1 by 0, which is again undefined, and the cotangent of 1530 will be 1 over tangent, that is 1 over undefined, which is equal to 0. Okay, so this is how we find the trigonometric ratios of an angle which is coterminal to some special angle. So all the magic lies in the values of k and theta. We have to find the value of k and theta. We are going to replace it over here, which will prove that these two angles are coterminal, and we will try to find theta as one of these angles, because we know the trigonometric ratios of these angles, and with the help of trigonometric ratios of these angles we can find the trigonometric ratios of theta dash, which will be the angle that is given to us in the question. So let us try one more example. Now suppose if the angle is in radians. For example, question number 5, part 9. The angle is 407 by 2 pi. Angle theta dash is 407 by 2 pi. Now it is in radian. The method will be the same. The only difference will be that we are going to divide by 2 pi, not by 360, because it is in radian, and in degrees 360 degrees in radians is equal to 2 pi. So the method will be the same. We are going to write theta dash as theta plus k times 2 pi, 360 degrees. To find k, we will repeat the same procedure. We are going to divide this angle by 2 pi. Okay, we are going to divide it by 2 pi or multiply it by 1 over 2 pi. This will be equal to approximately, if I use the calculator, 407 divided by 4, which is equal to 101.75. So from here k will be equal to 101. Okay, now to find theta, we have to subtract theta dash from k times 2 pi. theta dash is 407 by 2 pi minus k is 101 into 2 pi. This can be written as 407 by 2 minus 202 pi, which will be equal to, by using the calculator, 2407 by 2 minus 202. That is equal to, this will be equal to 3 by 2, okay, and pi. So we know that 3 by 2 pi is actually the angle of 270 degrees. 270 degrees in radians is written as 3 by 2 pi, which is a special angle whose trigonometric ratios we already know. It means that the trigonometric ratios of 407 by 2 pi will be equal to 3 by 2 pi. Sine of 407 by 2 pi is equal to sine of 3 pi by 2, okay, which is equal to minus 1, because sine of 270 degrees is equal to minus 1. Its cos is 407 by 2 pi will be equal to cos of 3 pi by 2, which is equal to 0. Okay, and with the help of these two we can find the tangent, okay, cotangents, secants and cosecant. Okay, cosecant will be the reciprocal of this, that is minus 1. Secant will be the reciprocal of 0, 1 over 0, which will be undefined. Tangent will be sine over cos, which again is going to be undefined. Okay, so tangent of 407 by 2 pi will be equal to sine over cos 1 over 0, which is undefined. And by taking reciprocal of these, we can find the cotangent, secant and cosecant of 407 by 2 pi. Now let us try the last example, in which we have to do an extra step after this, okay, to get to the special angle. Even these two steps will not be enough for those questions. Let me try one of those questions for you. That what are you going to do if these two steps are still not enough to find the special angle? How to find the special angle? This will be, I think, question number 6. The last part, it is one of those questions. First of all, it is a negative angle, okay, and here we are going to use the property of sine and cosine, which says that sine of negative theta is equal to negative sine of theta, and cos of negative theta is always equal to cos of theta. Okay, sine of negative theta is equal to negative sine of theta, and cos of negative theta is equal to cos of theta. To make it more visible, sine of negative theta is always equal to negative sine of theta, and cos of negative theta is equal to cos of theta. Now if you have a negative angle, then you can use this property and put the negative sign aside, and after that you can apply the same method. For example, in this question, sine of negative 1035 will be equal to negative sine of 1035. We will first find the sine of this, which will give us the sine of negative 1035. Similarly, to find the cos of this angle, we will have to find the cos of positive 1035. This is the relation between the trigonometric ratios of positive and negative angles. If you know the sine of 1035, with the help of that you can find the sine of negative 1035 by simply multiplying it by negative sine. So first we are going to find the sine of this positive 1035, and which will, with the help of which we will be able to find the sine of negative 1035, and after finding sine and cos, we can easily find tangent, cotangent, cosecant and secant. Okay, but the main target is to find the sine and cosines of positive 1035, because it will lead us to the sine and cosine of negative 1035 and to other trigonometric ratios. The first step will be the same as we did before. We will take theta dash to be equal to 1 1035. And again, to find k, we have to write it as theta plus k times 360 degrees. Okay, we will attempt to find k. K will be theta dash by 360 as we did earlier. 1035 divided by 360. This approximately gives us the value 1035 divided by 360. This is equal to 2.875. Now this gives us the approximate value of k. Okay, we will take k equals to 2, and if it does not work, we will try to take k equals to 3. So the k will be either 2 or 3. Okay, so let us try 2 and let us see whether we get a special angle or not. If we fail to get a special angle, we will change our k and take it equal to 3. Okay, this just gives us the approximate value. Okay, just a guess about k, because k can be any integer. So take an integer which is near to this one, either it is 2 or 3. Okay, so it just gives us an approximate value. Let us try if k is equal to 2, theta will be theta dash minus k times, we know that it is k times 360. If we take k equals to 2, what will be theta? Theta dash is the angle that we are trying to find, 1035 minus, if k is taken to be equal to 2. Let us see whether we get one of these angles or not. Okay, if you subtract these angles, 1035 minus 2 times 360. Okay, it is equal to 315. We know that this angle does not belong to this group. We don't know the trigonometric ratios of this. So if it comes out to be some other angle, then try the next integer which is near to this number. The next integer that is very near to this number is 3. So we are going to try this. We won't use k is equal to 2 because we are not getting an angle which is one of these. Let us try 3. Okay, if you try 3, what will be theta? Theta will be theta dash minus k times 360. If you take k to be equal to 3 minus 3 into 360, what do we get? 1035 minus 3 into 360 is equal to negative 45. We know the trigonometric ratios of 45. With the help of that, we can find the trigonometric ratios of negative 45 because we know this property. So it means that here we can find the trigonometric, we can get the trigonometric ratios of 1035. Okay, so our special angle in here is negative 45 degrees. Okay, this is the angle which will lead us to find the trigonometric ratios of 1035. So now let me erase this because we now know that theta is 45. Okay, now let us start from here. Sine of negative 1035 is equal to negative sine of 1035, and sine of 1035 will be equal to sine of negative 45 because these two are coterminal angles, as we have already found out. Now this sign can be shifted in front of the sign. Here it will be negative of sine of 45 using this property. Okay, sine of negative theta is equal to negative sine of theta. This will become minus minus plus, and we know the sine of 45 is 1 over under root 2. Similarly, cos of negative 1035 will be equal to cos of 1035, and whose cos is equal to negative 45. We know that cos of negative theta is equal to cos of theta according to this property. The cos value of cos is not affected by the negative sign. So this will be equal to cos of 45, which is equal to 1 over under root 2. Now tangent of negative 1035 can easily be find it by, we know that this will be equal to negative sine of this over cos of negative 1035, which will be equal to sine of negative 1035 can be, we can find out with the help of these two, is equal to 1 over under root 2 over 1 over under root 2, because we know the sines and cosines of this angle, so we can find all the other ratio with the help of these two. Similarly, its cosecant will be, we know that cosecant negative 1035 is equal to 1 over sine, reciprocal of sine, so it will be the reciprocal of this 1 over under root 2, so it will become under root 2 over 1, which is under root 2. Similarly, secant of the angle is always the reciprocal of its cos, so secant of negative 1035 will be the reciprocal of its cos, which is equal to under root 2. So this is how you can find the trigonometric ratios of many angles which are coterminal to one of these angles. Okay, and that's it. That's all for today.